today's session we will start the discussion on the third category of database architecture, which is called as distributed databases. So in the first videos we have seen some basics of distributed databases, and we have also seen the basic features of distributed databases, where it is being used, and the architecture of the different sites that are connected to the different sites through the high-speed connection network, and some basic properties are also mentioned in our initial videos about the basics of distributed databases. So in this session we will be discussing in detail about the distributed databases. So what do you mean by distributed database system? So it is actually a database system which consists of loosely coupled sites that does not share any physical component. So loosely coupled architecture means the site or the nodes will not be sharing any physical memory portion or any disk portion. That means they are not using that in a sharing mode. So every sites that are, so this is the architecture of distributed system, where we'll be having different nodes available, and all the nodes are connected through a network. So this can be called as S1, S2, S3 and S4. All these are sites, or we can call it as different nodes, and all the nodes are connected to a single connection network, high-speed network. So every site will be having its own memory and its own disk. So independently the different sites are residing on different locations, and they are only connected through a communication network, and all the communication between these sites will be happening only through this high-speed internet connection. So that is why it is called as loosely coupled architecture. Now as I was mentioning, the database systems that run on each site are independent of each other. So site 1, site 2, site 3, every site will be having its own database system, and they will be running locally, and they are acting as independent database system on each of these independent sites. Now when we try to do some transaction, they may access data from one or more sites. So that is the benefit of using distributed database system. Even if the data are distributed, even if the sites are distributed, even if the memory or disk are distributed, if we require some data for a particular transaction from a particular site, it can be initiated from that site and can have access to the data that may be stored in different sites, and it is possible to access those data through the support of a distributed database system and with the support of a interconnection network. So in this distributed architecture, the database transactions can be executed by initiating the transaction at one site and by accessing the data items that may be residing on different sites that are located in different places. So that is the main advantage of the distributed database system. Now, what are the different types of distributed databases? So there are two types. One is called as the homogeneous distributed databases, and second one is called as heterogeneous distributed databases. So what are the features of homogeneous distributed databases? So the major thing is every site in the distributed architecture will be using the identical software. That means every site will be following a single DBMS. For example, site 1 is following Oracle DBMS, site 2 and site 3, and all the sites, if they are following the same software, database software like Oracle or MySQL, if they are common for all the sites, it can be called as a homogeneous distributed databases. And these sites, they are aware of each other as they are following the same software. They are aware of each other and they agree to cooperate in processing user request. So when they are using the same software in all the sites, it will be an easier task for the different user from different sites to access the database, because when we are dealing with the same type of software on different sites, it will be the same task, because all the access procedures will be same for all the sites, so we can easily have the communication between different sites. Now similarly, every site will be having its own autonomy. So even if different sites are there and different sites are maintaining the same software, they are having their own autonomy. Autonomy means they are having their own freedom. Even if it is in distributed format, but every site will be having its own freedom. They can have their own operations, and they can have some freedom. Some freedom is given to the same site, and they can have some freedom on the execution of the data present in its local memory or disk. So they can deal with the data present in the local site. So for that, they will be having some additional freedom that will also be permitted in the case of a homogeneous distributed databases. That means they can change the schema or model, what model it can use, whether it is a relational model or whether it is an object oriented model. They can follow different schemas, and also they can change the software also. But in the homogeneous system, if we change the software of one distributed site, the same must be there in other site also. So this is another feature of homogeneous distributed databases. And overall, even if we are having multiple number of sites available, it feels like we are having a single database system available for our transaction purpose. So these are the features of homogeneous distributed databases. But when we use the second category, that is heterogeneous distributed databases, so what are the features of these distributed database system? So the main thing is the different sites will be using different database models or schemas, and also they will be using different database softwares. Maybe one site is using MySQL software, some other site will be using Oracle, some other site will be using some other database system software. So that may be the situation. So it won't be uniform for all the sites. So it will be slightly complicated when compared with homogeneous distributed databases. So difference in schema is a major problem, because if one is using relational model and second one is using object oriented model, the query processing will be a difficult task when we are working on a transaction where we need to have communication between different sites. And also there is difference in database software also. There also it will be a problem, because there will be slight differences in the working of an Oracle database system and a MySQL database system. There will be some technical differences between these softwares. So this software communication is also a major problem when we are using a heterogeneous category of distributed database system. And also the sites may not be aware of each other in this particular case, but you can see in homogeneous distributed databases they are aware of each other. Okay, but here in this case they are not aware of each other, as they are using different software and different data models. So it may provide only limited facilities for cooperation in the case of an entire transaction processing. So homogeneous distributed databases are always good. Heterogeneous are actually because we cannot say that a site that maintains a database in a country cannot be similar in the case of the data stored in some other country, but they need to have some communication for the transaction purpose. So that situation we need to do some additional operations as part of the DBMS system to make these two in a common platform, to bring the schemas into a common format and to bring the software facilities into a common format, and those additional activities to be done as part of a heterogeneous distributed databases. So it is a slightly complex database system, and but we are using heterogeneous distributed databases also, but it is always better to or easy to use homogeneous distributed databases in practical. Now in the distributed architecture or distributed database system, one of the major concern is about the data storage, how the data is being stored in these distributed sites. Now the data storage can be distributed by replicating the data. So one of the major term related to the distributed data storage is replication of data. Replication of data means the data or some data will be replicated or repeatedly available in different sites. That is called as replication. The same data, for example, some account information that will be available in more than one site. That is called as replication of data. So one of the data storage mechanism is the same data can be replicated on different sites, and also by fragmenting the data. So replication and fragmentation. So what is fragmentation? Fragmenting the data means a large relation can be fragmented. A large relation can be fragmented into different fragments. That means some portions of a relation can be considered as a fragment, some other portion of a relation can be called as another fragment. We can divide the relation into different fragments, and these fragments can be stored in different sites. Maybe we can replicate this fragment also. The different fragment can also be replicated. So the entire relation can be replicated. The different fragments can also be replicated. So we'll be storing the data in different sites in both replication format and in fragmentation format. So what is actually replication? That is the system maintains multiple copies of data which are stored in different sites, because it is for the faster retrieval and fault tolerance. That means the same set of data will be copied or they are maintained in different sites. Why it is? Because if we want to retrieve the data very faster, we can access the data from the site where we can easily access. That is one thing. And second thing is fault tolerance. If the site where the data resides is under failure, we will easily get the data from some other site where the replica of that data is residing. So that is called as fault tolerance, which is the major advantage of using replication. Now what about fragmentation? That is, a relation is partitioned into several fragments. A sub portion of a relation can be called as a fragment, and these fragments will be stored in different sites. Now we can have the combination of replication as well as fragmentation. So as I was mentioning, the same relation can be divided into different fragments, and these fragments can be replicated on different sites. So either entire relation can be replicated, or we can divide the relation into different fragments, and these fragments can be replicated. So replication, fragmentation, and combination of replication and fragmentation. Now data replication. A relation or a fragment of a relation is replicated if it is stored redundantly in two or more sites, that I have already mentioned. Now the different subcategories of replication. We can have a full replication of a relation. It is the case where the relation is stored at all sites. That means the entire relation is repeated or redundantly stored in all the sites. So if you are having a relation R, the relation R is replicated on all the sites present in the distributed architecture. That is called as full replication. So basically replication means some data are replicated, but full replication means the entire relation is stored in all the sites. So there won't be any problem with accessing those data that are being fully replicated, because some of the site, if most of the sites are under failure, but still we will be getting the data from the site which is active. Now fully redundant databases are those in which every site contains a copy of the entire database. So fully redundant database, that is where we are having full replication available, where the entire database is present in every site. That was actually mentioned in the full replication topic. Now the advantages of having this replication, three major points. One is availability, second one is the support of parallelism, and third one is reduction in data transfer. So what do you mean by availability? Failure of site containing relation R does not result in unavailability of R if replicas exist. So I was already mentioning, even if one site is under failure, the data is always available in some other site. So higher availability. Then parallelism means the execution can be done in parallel on a relation R. So in the previous sessions we were discussing about parallel databases. Now if the same relation is already being replicated on different sites, for the same relation, different queries can be applied parallelly on the same relation, because these relations are present in different sites and they can be executed in parallel. And reduction or reduced data transfer, because if relation R is available locally at each site containing a replica of R, that means normally if especially for full replication also, if one site initiates a transaction, normally the replica of relation will be present in that site also. So the transaction can access that relation from the same site itself without having a data transfer or communication to some other site. So full replication will always reduce the data transfer, and it depends on the number of replicas. So if we are having some few replicas available, we can reduce the data transfer. But if you are not having any replicas available, always the data must be collected from other sites. So for that collection we need to communicate with the network, and every time we need to have some message request and response through that particular network. So there will be always more data transfer for accessing those data from different sites. So these are the three advantages of using replication. Now let us see some of the disadvantages of using replication. The first point is increased cost of updates. If the same relation is available in different sites, if one of the updation happens at one site, every replica must be updated. That is not an easier task, because in database the data must be consistent, because even if we are having replicas available, we are considering this as a single relation or single fragment. So if one of the site with that replica updates some data, the same updation must be reflected on other replicas also. So that is not an easier task, so which is a disadvantage of using replica or replication. Now the second disadvantage is increased complexity of concurrency control. So what do you mean by concurrency control? Concurrency control means accessing the same data item by multiple transactions. So concurrent updates to distinct replicas may lead to inconsistent data. If means the same item is being accessed by different transaction, and if they are selected or collected from different replicas, the same item cannot have an access in that way. That cannot be permitted. So for example, an account for a particular customer is being accessed by one transaction T1 on one site. At the same time, another transaction T2 is trying to access the same account from other site, and maybe the same account will be replicated in some other site also, but that cannot be permitted. So there should be some concurrency control on the access to the data item which are replicated on different sites in the distributed database system. So the solution is to have only a primary copy on every data item. So we should maintain a primary copy even if it is having replication. Maintain one site with primary copy, and by using primary copy mechanism, we can all the reference will be moving towards only that particular site, and we can have the concurrency control that can be done in a perfect mode if you are using a primary copy mechanism. So later we will be discussing about various concurrency control mechanisms followed in distributed database system. Now data fragmentation. So here fragmentation means a relation R will be fragmented or divided into different fragments like R1, R2 up to Rn, which contains some information or sufficient information to reconstruct the entire relation R. Now, what are the different types of fragmentations? One is horizontal fragmentation and second one is vertical fragmentation. Horizontal fragmentation means the relation will be divided in horizontal way. That means tuples are divided. Each tuple of relation R is assigned to one or more fragments. So some tuples are selected to form a fragment, maybe based on some condition, whatever it be. So horizontally we are dividing the relation, that is called as horizontal fragmentation. Now when we are fragmenting the relation horizontally, so in some situation we need to get the original relation, so there we can apply a union operation on all the fragments which are created from the larger relation R. Now vertical fragmentation means the relation is vertically being fragmented, means column wise or schema based. The schema for relation R is split into several smaller schemas. So some details of this relation: some columns are selected as one fragment, some other columns are selected as another fragment, some other columns are selected as other fragment. So while doing these type of fragmentation, it should have, for every fragment we should have a key, a candidate key or a primary key or a super key to be maintained in order to ensure the lossless join property, because we need to join these fragments again for getting the final relation again. So we need to maintain an additional key field with every fragments that are present in or that is being generated from this particular relation. So we are using a special attribute called as tuple ID to form the these fragment. So if with every fragment we will be adding an additional field called as tuple ID, so that by using that tuple ID attribute we can join the fragments. So the original or initial relation can be obtained by joining all the fragments on or by using the attribute tuple ID of all these fragments. So horizontal fragmentation can be means the relation can be obtained by using union of all the set of tuples, and in vertical fragmentation the original relation can be obtained by joining all the fragments by using a common attribute tuple ID of all the fragments. Now one example is given. A horizontal fragmentation of an account relation by branches means we will have all the tuples or all the account details on a particular branch where branch is equal to Cochin. So all the tuples are selected for a particular branch. Now for vertical fragmentation we will see one example where we need to separate the details of an employer, means an organization, to get only the salary details, means employee number, salary. Only the salary informations are separated. So the relation will be having other employer related, other purchase and other several the fields will be there in the initial relation, but we need to only get those data related to salaries. So only some selected attributes will be retrieved as a fragment, and these fragments can be stored in different sites of distributed database architecture. Now the different advantages of fragmentation. We will see the advantages of horizontal fragmentation. Horizontal fragmentation will always allows parallel processing on arguments, on fragments of a relation. So the tuple set, the different tuple sets that are present in different sites can be accessed parallelly by different queries, and it also allows, horizontal fragmentation allows the relation to be split so that tuples are located where they are most frequently accessed. So some tuples are there in site 1, some tuples are there in site 2. So we can locate those tuples which are frequently used on the given site. So in that way we can distribute the fragments. So these some fragments are always required in like in our previous example, the account details of a particular branch. So those tuples are always required in that particular branch or site only. So we can easily locate on the frequently accessed tuples. Now the advantages of vertical fragmentations are, it allows tuples to be split so that each part of the tuple is stored where it is most frequently accessed. So for the entire relation, a part of tuple will be divided into fragments. So the portions of tuples are actually part of a particular fragment. So as in horizontal, here also we can maintain portion of a relation in vertical format can be stored in different frequently accessed sites. Similarly, the addition of tuple ID attribute for joining purpose, it allows efficient joining of vertical fragments. So when we are doing vertical fragmentation, we are always adding an additional attribute, that is tuple ID, and this tuple ID will always help to rejoin the fragments to form the original relation. And also it allows parallel processing on a relation on these vertical fragments. So into these fragments, on these vertical fragments, for different fragments, if different queries need to execute in parallel, they can apply this parallelism on all these fragments. Now similar to the replication, the vertical as well as horizontal fragmentation can be mixed. That means fragments may be fragmented into an arbitrary depth. So the fragments can be vertical fragments can be fragmented. That means some columns are selected, and this can further be vertically fragmented, horizontally fragmented. Now similarly, we are having a horizontal fragment available. This can be further vertically fragmented. So these two can be combined. So These are the advantages of fragmentation. Now the third property of distributed databases. So first of all, we are discussing about replication. Second, we were discussing about fragmentation. Now third feature of distributed databases are data transparency. Data transparency. What is the meaning of transparency? It is the degree to which system user may remain unaware of the details of how and where the data items are stored in a distributed database system. So transparency, data transparency is the degree in which, means how extent the user is not aware about the inner details of data storage and other informations. Means if I require some account details, I'll be submitting the query and I am unaware about the storage, where it is stored, in which site it is stored, in which fragment, whether there is a number of replicas available. We are unaware about all this information. Still we can access that data without knowing all this information. So that degree in which the user may unaware of these details, that is actually called as data transparency. Now there are three types of transparencies. One is called as fragmentation transparency. Fragmentation transparency means the user is unaware of having different fragments of a particular relation. If I want to access some data, I will enter the query and I will be getting that data. I don't know whether the relation is fragmented into different tuples or different attributes. I am unaware of that. Still I will be accessing all the required information by using the transaction statement. Similarly, replication transparency means the user is unaware of having replications. We don't know, so I want to get some account details. I don't know whether this account or bank details are replicated on different sites. I don't know that. If I request for that data, I will be getting that data without knowing the details of these replications that are present in various sites. Similarly, third one is location transparency. So if I want to access a particular relation, particular data, I will be entering the transaction statement or query and I will be getting that. I don't know in which site that data is present. Without knowing the location where the data is present or stored, I can access the data. So this is actually called as transparency. The user is unaware of the details. What are the details? The details like whether there is a number of fragmentation available, whether there is a number of replicas available, whether the data is stored in which location. Without knowing all these internal details, the user can easily access the data. So that is the property called as data transparency. So despite of transparency issues, data item must always be uniquely identified in the whole distributed database. So whatever be the issues related to transparency, the data item must be always identified by the user when we are using the distributed database system. Now in this distributed database concept, we are usually using a term called as data items. Data items are sometimes it can be a single value, or it can be a group of values, it can be a group of tuples, or it can be a group of attributes, or it can be an entire relation also. Whatever be the data item. So sometimes I require the details of a particular customer. It is actually a tuple. Sometimes I need to get some information of several customers. So it will be a set of attributes. So whatever it be, we are considering different data items, maybe some rows or columns or attributes or tuples, whatever it be, even a single item, anything can be called as a data item. But internally, we should have, the system should have a name associated with each of these data items. So there are four criteria related to the naming of data items. Whatever be the data item, so you can consider X as a data item, or an account number can be considered as a data item, or the details of a customer can be considered as a data item, whatever it be. So every data item must have a system-wide unique name. So every data item must be identified by using a unique name. There should be a unique name for each data item. Second thing is, it should be possible to find the location of data items efficiently. So we should easily find out the data item by finding the location of that particular data item. So the naming must be given so that we can easily find out the location of that data item. It should be possible to change the location of data items transparently. So sometimes if you want to move the data from one location to another location, it must also be done transparently without having much information that is given to the user. So the user can easily move the data item from one location to another location without knowing any internal details. And similarly, every site should be able to create new data items autonomously. So they can create their own data items in each of the sites. So every site is having the freedom to create their own data items. So these are the four naming criteria. So while providing some name for the data items present in these distributed databases, we should follow these four criteria. So the criteria based on the uniqueness in the name of each data item, the location of data item, change in location, and creation of new data items by themselves. Now there are some naming schemes available. The first one is called as centralized naming scheme by using name server. That means we are having a concept called as name server, through which we are providing the name for different data items. So as we are following a server, we are calling it as centralized naming scheme. So the structure followed in this scheme is the name server, that is one server will be the server for assigning the names on all the items. So a single server will be assigning the names for each of the data item. And also each site maintains a record of the data items present in that particular site. So the local data items details will be recorded by the same site where that data items reside. Similarly, the different sites will ask the server to locate the non-local data items. So if I want to access one item from another site, I will ask the name server where this particular data item name is present. So every request must be gone through the name server for locating a non-local data item. So this is the structure of a name server or centralized naming scheme. Now the advantage of this scheme is it satisfies all the first three naming criteria. That is, you can have unique name. Unique name can be given by the single server. Second thing is the location can be found by the single server, and also we can change the location. The location change can be permitted by the single name. So all the requests that is sent to that single name server, and the server will deals with the changing of location of various data items. But this scheme does not provide, that is the disadvantage portion, does not satisfy the criteria 4. What was that? It cannot create its own new data items. So because everything must be requested through the name server, so no site can create their own data item. It is possible only by referring to the name server. So name server is a potential performance bottleneck here, because all the requests are moving towards this name server. So always the server will be always busy, or it is tight, so it can be technically called as performance bottleneck to the name server. Now the single point of failure, that means if the server fails, then their distributed architecture processing, the database processing will be under failure, because we are having only a single name server present. If the single name server criteria is being followed. Now the second mechanism is the use of alias. Alias means, we are giving different names for the same item, that is called as alias. Right, we are giving different names for the same item. So alternative to the centralized scheme, that is the name server scheme, now in this system that uses aliases, every site prefixes its own site identifier to provide the name. That means account is the data item. Account that is present in site 17 will be given the name site17.account. That means the data item will be prefixed with the site number. Now if the same account is present in some other site, it will use an alias. What is that? Site18.account. If the same account is present in some other site, like site20.account, so every site the data item will be prefixed with the name of the site or the number of the site. So it fulfills having a unique identifier. It can easily identify by using a unique name, and it avoids problems associated with central control, because now if an account is required, its corresponding site will be referred. It is not asking to a particular server, it is not passing through a server. The request will go to the site where the account resides. But it fails to achieve location transparency, because location transparency means the user is unaware, but the data is stored in site number dot data item name. So automatically when we try to access account, it must be accessed like site17.account. So that location transparency feature is now failed, because by knowing the site name only we are accessing the data item. So that is one problem with the usage of alias. Now in order to provide a solution for this situation, now we need to have a set of aliases for data items. Okay, so initially we were discussing about, so I was talking detail about aliases initially itself, because initially it was having each account or each item was present in a particular site with site number. There we are having the location transparency problem. But if it is present in different sites, we are actually providing aliases. So I was mentioning this before itself, like the same item with different names. The same item like site18.account. We are giving different names for the same item. These different items will be storing the mapping of aliases to the real names at every site. So alias will be there. We are providing a different name for each data item that will be mapped to the real names at every site. Now the user can be unaware of the location of data item where it is present. So site17.account is the problem, but we are avoiding that by providing a different name for that particular data item without providing the direct site number of that particular site. So but these names, whatever names we are providing, will be mapped to the real names at every site. So that is connected, but it is slightly complex. So we can reduce the bottleneck of central server in the case of name server naming concept. So the second mechanism for providing names to the different data items is by giving alias names for the same item in different sites, so that we can have the location transparency property which can be maintained in the distributed database system. Now that is all about the basics of distributed database systems. So in this video we were discussing about the basics of distributed databases, the types of distributed databases like homogeneous and heterogeneous database systems. Then we have seen different properties of distributed databases like replication, fragmentation, features of replication and features of fragmentation, types of replication and types of fragmentations. Then we have seen the other properties like the the naming and the criteria given for providing the names of various data items, and also the property called as transparency and various categories of distributed transparency. The different types of transparencies that can be applied to the data items present in distributed database architecture. Now that is all about the basics of distributed database systems, and in the next video we will be discussing about distributed transactions in detail. Thank you.